Hello. Um, so I'm your instructor, Spence Pilcher, and what I'm going to do today is look at some problems involving dimensional analysis. Dimensional analysis is very important in chemistry because you can use dimensional analysis to solve a variety of different problems. And so if you find this useful, I can do more problems. Just let me know kind of what topics you'd like me to cover, and I can go over some more. And throughout the semester, I'll go ahead and pick some topics as well, like stoichiometry and things that I think are really important. So dimensional analysis we're going to look at. So this is the process used for dimensional analysis. First thing you do is write down the measurement, and then you multiply that by a conversion factor, and the conversion factor is equal quantities. And you want to multiply it by the conversion factor so that the units of measurement on top and bottom will cancel out. So we'll see exactly how we do this when I work some problems. And then you just continue on until you reach your desired answer. And then density and percents may also be used as conversion factors. Express percent as a conversion factor as a part of 100 to the whole. And we'll see exactly how to do that while I'm working some problems as well. So let's go ahead and get started. If I can find some chalk. Okay. So first question. It says a recipe for shark fin soup calls for 3 quarts of chicken broth. If 1 quart contains 4 cups, how many cups of broth are needed? So I'm going to write down my measurement first thing. So my measurement is 3 quarts. And you could put chicken broth here. I'll put CB chicken broth. So that's my measurement. Now my conversion factor, I'm given 1 quart contains 4 cups. Okay, so those are equal quantities. 1 quart is equal to 4 cups. So you want to put units on top and bottom that cancel. So I have quarts on top here, so I need quarts on bottom here, so it'll cancel. So 1 quart is 4 cups. So quarts cancel out, and I'll be left with my answer how many cups of broth are needed. So you multiply things on top, divide by quantities on bottom. So I take 3 times 4, so 12. So I get 12 cups of chicken broth are needed. Let's go on to the next one. It says a recipe for salsa requires 3 cups of tomato sauce. If only metric measures are available, how many milliliters of tomato sauce are needed? So I'm given the conversion factor here as well. I'm given that 1 cup is 236.588 milliliters. If you don't know a conversion factor, you could always look it up. So I have 3 cups of tomato sauce. Again, I'm just going to use my conversion factor. 1 cup, so cups on top here, so I need cups on bottom here. So get out my calculator. So 3 times 236.588. So I get 709.764. So if I look at this, now conversion factors are assumed to have infinite number of significant figures. So you want to go by the significant figures in your measurement. And so the significant figures in my measurement, 3.0, are 2. So I want my answer to reflect 2 significant figures. And so 709.764, let's write down here. If I went to 2 significant figures, then that'd be 710. So 710 milliliters would be my answer. Next problem. If you want to, this PowerPoint here that I'm working these problems from is available, the same link on Blackboard, so you can print that out if you want to. So how many kilograms does a 185-pound person weigh? So again, I'm going to write down my measurements. So I know that there's 2.2 pounds in a kilogram. If you did not know that, you could look it up. Or if you knew there was 454 grams in a pound, what you could do is convert to grams first, then to go to kilograms. If I know 2.2 pounds in a kilogram, so pounds on top, the pounds on bottom here, so the pounds cancel out. I'll be left with my answer in kilograms. This time my numerical value here, 2.2, is on bottom. So I divide 185 by 2.2. So multiply by things on top, divide by quantities on bottom. So 185 divided by 2.2, I get 84.1 or 84.090909 by 1. Go to 3 significant figures. That's my measurement. So 84.1 kilograms. Now this one says if it took 3 weeks for a package to arrive, how many seconds did it take? So, does anybody know how many seconds in a week? I don't. But what do I know about weeks? I know there's 7 days in a week. So I'm going to use what I know. So I know 7 days in a week. So I'm going to write that down. So 1 week. Now I put that on the bottom so it'll cancel out. I know there's 7 days in a week. Do I know how many seconds are in a day? No. But what I know about days, I know how many hours are in a day. So now I have how many hours are in 3 weeks. Okay, now a lot of people may know how many seconds are in an hour, because you can take 60 times 60, but if you didn't, you go to minutes first as well. So 1 hour, 60 minutes, in 1 minute, 60 seconds. Or you could just say 1 hour, 3,600 seconds, and you're going to get the same answer. So hours cancel out, minutes cancel out, you'll be left with your answer in seconds. So multiply things on top, so 3 times 7 times 24 times 60 times 60. This is the number I get. Okay. I don't know if I look at my measurement 3 weeks. I just have 3. It does say 3.0 weeks, and so it's just one significant figure. So I don't know if it was actually an estimate, if it actually took 3 weeks and 2 days, or 2 weeks and 6 days. You know, you don't know the precision that measurement was made with, so you can only put one significant figure in your answer. So how can I put this with one significant figure? Well, I can use scientific notation, or you could just say 2 million seconds as well. I'm going to use scientific notation. So I'm going to round this up to 2. It's going to be times 10 to the, I'll move my decimal point here. 1, 2, 3, 4, 5, 6. When you do scientific notation, put numbers in scientific notation. You can just think if it's a big number, this is going to be positive. If it's a small number, less than 0, this will be negative. So 2 times 10 to the 6 seconds. So let's go on to the next one. So it says if a tree grows 3.5 feet in 1 year, how fast did it grow in miles per hour? So I've got two different things I have to convert on this one. So I got that the tree grows 3.5 feet in 1 year. Okay, now I want to convert that to miles per hour. So the first thing I can do is convert feet to miles. Okay, so 5,280 feet in a mile. And if you didn't know that, you could look that up. That gives you how many miles it grew in 1 year. And it should be a very small number because you wouldn't expect a tree to grow very many miles in a year. Okay, now I want to convert years to hours. What do I know about years? I don't know how many hours are in a year, but I do know how many days are in a year. So in 1 year, there's 365 days. So my years, notice how my year is on bottom here. So I put year on top here so it cancel out. So now what do I have? Miles per day. Okay. I want miles per hour. So again, days on bottom, put day on top here. And I know there's 24 hours in a day. So days cancel out, years cancel out, feet cancel out, and I have miles per hour. So this time I want to take 3.5, divide by quantities on bottom. So I take 3.5 divided by 5,280 divided by 365 divided by 24. And I get a very small number, which is expected because you don't think of a tree growing very fast in miles per hour. I'll put that in scientific notation. 1, 2, 3, 4, 5, 6, 7, 8. And I know it's going to be a minus because I know it's a small number. So 7.5 times 10 to the minus 8 miles per hour. Now I did two significant figures here because I had two significant figures in my measurement. Now here's a problem using percentages, so I'm going to use a percent as a conversion factor. Now some of your mastery online homework assignments, you have to do this using percents as a conversion factor. So it says oxygen makes up 46.7% by mass of the Earth's crust. How many grams of oxygen are present in a sample of the Earth's crust as a mass of 325 grams? So I have 325 grams. I'm going to go ahead and write this out. Of the Earth's crust. I want to know how much oxygen I have. So if we go back to that initial slide, it says density in percents may also be used as a conversion factor. Express percents as a conversion factor as part of the 100 parts of the whole. So what that means is I know percent is a fraction of 100. So if I have 100 grams of the Earth's crust, from this percentage, I know 46.7 grams of that is oxygen. So that way, grams of the Earth's crust cancel out, and I'll be left with my grams of oxygen, which is what the question asks about. Okay. And it's the same thing as just taking 46.7% of 325 grams, you get the same answer. But this is how you do it using dimensional analysis. So times 46.7 since that's on top, and divide by 100 since that's on bottom. So I get 151.775. So round that to three significant figures. 152 grams of oxygen. Here's one where I'm going to use density as a conversion factor. So this milk has a density of 1.04 grams per milliliter. What is the mass of milk in a 1 quart container? So I'm going to assume it's 1 quart of milk. So my density is given in grams per milliliter. Okay. Now I don't know how many milliliters in a quart. I could probably look that up, how many milliliters in a quart. But if I go back to a previous problem, I'm given the milliliters in a cup. And this one I'm given the cups in a quart. And so I'm going to say 1 quart. There's 4 cups. So quarts on top here, the quarts on bottom here, so it'll cancel out. Now I have cups. 1 cup, 236.588 milliliters. So now I have milliliters, and my units for density is grams per milliliter. So I'm given 1.04 grams per milliliter. So since milliliters is on top here, I need milliliters on bottom here. So when you write your density out, wherever units you're trying to cancel out is what you want to put on the top and bottom. So if I put 1.04 grams on top, milliliters would be on bottom. If I put 1.04 grams on bottom, the milliliters would be on top. So if I'm trying to cancel out grams, I divide by the density. If I'm trying to cancel out milliliters, I multiply by the density. So you can solve this equation also by using density equals mass divided by volume and rearrange the equation to solve for your mass. This is the way you do it with dimensional analysis. Milliliters cancel out. I'll be left with my answer in grams. So 1 times 4 times 236.588 times 1.04 get 984.2 grams. 1 quart container, 1.0. So I'm going to use that as my conversion of my number of significant figures too. So I'm going to say 980. So that shows my uncertainty in the measurement from the measurement I have up here. Last one. Again, I'm going to be using density as a conversion factor. So I'm given the density of air. Now I'm asked how much will 550 liters of air weigh in pounds. So my density is grams per milliliter. So this is a volume, liters. So I need this measurement in milliliters so I can use my density as a conversion factor. So 1 liter is 1,000 milliliters. And then 0.0013 grams per milliliter. So again, my density goes on top here because I want milliliters to cancel out. So that gives me grams. Now I need to go from grams to pounds because it says how much it does it weigh in pounds. So you may have to look this one up. It's 454 grams in a pound. Or if you remember 2.2 pounds in a kilogram, you could use that as well. Grams cancel out. I'll be left with my answer in pounds. So 550 times 1,000, multiplying things on top, times 0.0013, divide by what's on bottom, 454. So get 1.5748, so let's see. By two significant figures here, so I'm going to say 1.6 pounds. Okay. Which you wouldn't expect air to weigh much, but you do have quite a bit of air, so it weighs 1.6 pounds. So I hope you found this useful, and I'll be recording more videos. Good luck with the homework. Let me know if you have any problems.